All right, welcome everybody. This is day 4 of Building for Digital Health, hosted by MIT Hacking Medicine in partnership with Google Cloud and supported by Apple Health. My name is Aditi Joshi, and I am your host and moderator for the week. We are in day 4 of our Tech Talks. Now, it's a daily 90-minute series of Tech Talks all week long, which will culminate into a 3-day MIT Hacking Medicine Hackathon this coming weekend. And I'm sure you all know how legendary their hacks are. So who knows what great product will come out of the hack this weekend. And I can't wait to see what you all come up with. Now, yesterday, we got an overview of Stanford Biodesign's Cardinal Kit. There is a prize at the hackathon for best use of Cardinal Kit, and Oliver and his Cardinal Kit team will be hanging out on Discord to answer any questions you might have on Saturday. So be sure to post those questions in their particular Discord channel. Now, tomorrow is our final day of Tech Talks, and we have a jam-packed agenda for you. We're going to kick off with the Android team. They're going to talk about the Google Fit API. We're going to get a deep dive by the Commons Project team. Now, they are a nonprofit funded by the Rockefeller Foundation, and they have developed the Android equivalent of Apple's HealthKit. Then we'll do a deep dive into Google Firebase. Now, you got a little bit of an intro yesterday during the Cardinal Kit presentation, but we're going to talk about what are the 3 steps you need to take to start using Firebase right away. And then we're going to wrap up our week-long Tech Talks with the awesome Professor Stern from Harvard Business School. And she's going to talk about the future of healthcare post-pandemic. I think that's going to be a great way to kind of wrap everything up and a great way to end the Tech Talk series for the week. For today, we have the Google Cloud Healthcare and Life Sciences product team with us. They will give you an overview of the GCP Healthcare API, talk a little bit more about how it leverages FHIR. Notice how FHIR is that common thread here all week long. And then we'll go into the Google Cloud NLP API, natural language processing, and wrap up with the Healthcare Data Protection Toolkit. So you'll definitely want to stick around for the entire 90 minutes. Let me introduce you to our very first speaker. And I just want to remind you real quick that if you do have any questions, you want to post them in our Discord channel, #discuss-Thursday. It's a great way for you to post links and to have a great conversation with other like-minded individuals like yourself. Our first speaker for today is Kalyan Pamarthy, who is the product manager for healthcare data interoperability and AI on Google Cloud's Healthcare and Life Sciences team. In his role, Kalyan manages the product portfolio for Google Cloud Healthcare API, and he works with health systems, health plans, and technology companies to manage healthcare data securely in the cloud and develop scalable healthcare AI applications. Now, Kalyan has over 15 years of experience in building healthcare and AI applications. Just a little bit of a background about him. He is an MBA from Wharton School of Business at UPenn, and he has a master's in science in computer science from the University of Minnesota, Twin Cities. I am going to bring him to the virtual stage, so let's give him a warm welcome. Hi, Kalyan.
Hi, Aditi. Thanks for having me.
Great. Thank you so much for being with us today. I know it's been crazy busy since the Healthcare API launched a few months ago.
Absolutely. Yeah.
Okay, I'm going to turn it over to you. I'm going to go backstage.
All right. Hi, everyone. Thanks for joining us today. As Aditi mentioned, my name is Kalyan Pamarthy. I'm the product lead on the Google Cloud Healthcare API, which we'll talk about a little bit. Joining me today is Dharmesh Patel, who leads our solutions team, focusing on healthcare interoperability as well. So I wanted to spend the time today talking about a few different aspects, focusing on building interoperable applications on FHIR. So we'll talk about healthcare interoperability and FHIR very briefly, but I want to focus on 2 areas within the Google Cloud Healthcare API. One is our capabilities about FHIR and managing data in FHIR, and other is a recently launched set of capabilities around managing user consent, which, as you all know, is really important in digital health applications. and in healthcare in general. And for the last 10 minutes or so, Dharmesh will join us to give us a demo on using Google FHIR services. So all of you can get started with that as you're building your apps this weekend and even after this weekend. So very quickly on FHIR. So as you all probably know, there's an interoperability challenge in healthcare, right? I mean, there's a proliferation of lots of different systems that have evolved over the last 30 to 40 years, solving some very specific problems in healthcare. So if you look around any healthcare system or any healthcare infrastructure, you'll find clinical systems that are storing and managing clinical patient data. You will find laboratory management systems that are really good at managing lab data for patients. You might find pharmacy management systems doing the same for pharmacy data. And so each of these systems is solving a very important need in the healthcare ID infrastructure. But what's happened over the past several decades is each of these systems has built their own set of data models, APIs, ways to access the data. And where we are today is that any new vendor or system or app developer trying to interface with these various systems now has this challenge of having to understand how all these different systems work together, their underlying data models, transformation of data, building web services that interact with these APIs. Some of them may not even have REST APIs, right? And so this becomes a big bottleneck in developer velocity as you're trying to build your apps. And so what we've seen over the past 10 to 15 years is a movement in the healthcare industry around standardization, and that's where technologies like FHIR come as the next generation of standardization, if I may say that. And so at Google Cloud, we're very focused on making those standards for data storage, management, and access available to developers such as all of you, so you can build your apps faster, right? Whether you're trying to build a web application, a digital health mobile app, or are you trying to build AI ML models on any of these types of data you see on the left-hand side of the slide, or you're trying to interface with any of these various systems, we want to make it really easy for you to be able to connect to these systems, bring in the data you need, store them privately and securely in the cloud, and be able to build your applications. And so the Google Cloud Healthcare team integrates with a lot of the other Google Cloud infrastructure, such as Google Cloud Storage, authentication, authorization. And so a lot of what you'll hear over the course of this week and through the weekend from our other teams at Google will fit well into this problem that we're trying to solve, right? And one of the ways that healthcare data exchange and data formats are being standardized is through FHIR, right? And so through the course of this week, I'm sure you've heard about FHIR a few times, but just as a quick refresher, FHIR is a standardized data format as well as a set of APIs for accessing data, right? And so this goes to the core of the challenge we were talking about before, where all these different systems are talking different languages in some ways of the data that they are storing and managing and exposing to others, right? And so FHIR is trying to solve that problem by proposing a standard data schema as well as a standard API specification. So as a developer, if you're, regardless of whether you're talking to an EHR system or a lab management system or any other digital app, all you need to know is the standard FHIR schema and the set of standard API calls you need to make. And you don't need to go learn about like every single proprietary data format, right? And so we're spending a lot of time in Google Cloud investing in FHIR and building services that enable developers to build on FHIR. So here's a quick example of what FHIR looks like for those of you who are new to FHIR. The standard structure has been defined, so it's really easy for, regardless of the clinical concept that you're looking at. In this example, I'm showing the concept of a patient. You'll notice that there's a clear format for where you can find the identifiers and metadata about the patient. what you need in terms of like defining the specific characteristics of the patient. In this case, if you look at extensions, there is a specific definition of US core birth sex, and so you can always go look up the specification. There's really no guessing on what the data format is, or inconsistencies in different systems. So anyone says they're following the FHIR standard, you can expect them to follow the specific published terminologies and value sets and other concepts, right? And then once you start working with FHIR, you'll notice that this is the standard pattern across all your resources. So that makes it really easy as a developer when you're working with healthcare data. Now, the advantages of working with FHIR, in case you're wondering, why FHIR versus like you just using any other underlying database technology or defining your own schema. Now, as you're starting to build your app, it might feel like a quick and dirty way to kind of just start off with a simple schema and build your own, right? While that sounds really good in the short term, it'll probably get you started. As you're thinking about integrating with other applications, and you most likely will have to in healthcare, right? I mean, there's a lot of different sources of data that you want to bring in over time as your app scales. It's important to think about the point where you have to start talking to all these systems. And once you do, developing proprietary schemas is going to become a problem. Right, and so we strongly recommend adopting the FHIR data model and the set of APIs early on in your journey of developing applications. So later on, when you're trying to integrate with any other clinical system, you don't have to worry about whether you have to update your schema, whether you've thought about how to, for example, model medications in your app, right, or conditions or observations. So the FHIR standard has thought about all these different concepts and has published their schema. And out of the box, if you're using any FHIR server, such as the Google Cloud Healthcare, you get support for a lot of these standard clinical resources, standard API calls to be able to create, update, search the data. And there's a lot of power that the FHIR standard gives you, and any FHIR server implementing the standard gives you. So you don't have to write a whole bunch of code. So you don't have to think about how to optimize FHIR searches for getting the set of medications for patients, for example, right? And so we strongly encourage developers to explore the FHIR standard and adopt it early in the development process. So jumping in a little bit into what Google Cloud offers in terms of the FHIR standard, I just want to start with an overall introduction of the Google Cloud Healthcare API. So the Google Cloud Healthcare API is our overarching surface for storing and managing various types of healthcare data in the cloud, right? And we operate on top of the standard Google Cloud infrastructure. And so the privacy and security guarantees that come with the Google Cloud infrastructure carry over to our healthcare API. We support a variety of different formats. HL7v2 messages is a common industry standard for exchanging clinical data. We support storage and fully managed web services for it. FHIR is the growing standard right now, and so we're seeing a lot of traction about application developers using the Google Cloud Healthcare FHIR APIs as the backend for their applications. We also support DICOM which is the standard in imaging data. There's two value-added services that we offer in terms of working with the healthcare data. One of them I'll talk about today, consent management, which is about helping developers and organizations store and manage consent in a structured, consolidated way, as well as healthcare de-identification, which is about de-identifying protected health information or private identifiers in healthcare. So research and analytics use cases can be driven off of the de-identified data, right? So the Google Cloud Healthcare API has been generally available for close to a year now. We have a lot of large health systems and payers using these solutions, as well as a lot of developers, digital health companies building their platforms on top of the Google Cloud Healthcare API. So I'd strongly encourage all of you to go take a look at cloud.google.com/healthcare. It's a lot of user guides, use cases, a lot of developer documentation to get you all started. So very quickly, the core of the FHIR service in Google Cloud Healthcare API is this concept of a FHIR store. So you can think about it as a database for storing FHIR data. And out of the box, you get support for all the various FHIR resources that the standard has published. So you don't actually need to think about how do you model patients or medications or allergies or claims. Think about any of the clinical concepts you commonly use in healthcare. The FHIR standard has modeled it, and we support it in our FHIR store. So we're taking away the burden of defining data schemas away from developers. The second important thing is a whole bunch of standard REST APIs that we provide to interact with this data, right? And so if you're developing a mobile app, you don't need to start writing core web services about creating patients, creating medications, searching for them. So we have all those fully managed APIs available out of the box that you can focus on building your higher level app web services that call these underlying REST APIs for data. And so in the demo that Dharmesh is going to show in a few minutes, you'll actually be able to see how the FHIR store is set up and how you can make some of these calls and directly integrate those into your applications. So if you were an app developer or a solution builder, typically how you would use the FHIR APIs is one of two ways, right? And if you're developing a mobile or web application, obviously we want developers to focus on the core business logic, right? I mean, of managing data, the front end, the middleware. We don't want you to worry about the aspects of, again, like I said, data schemas, the web services to interact with the backend, right? So if you were an app developer, you could hook in directly to the FHIR store and related APIs that Google Cloud has, and basically say, here's a patient, here's a medication, here's a condition, and the Google Cloud FHIR server has all the data structures to handle that. If you were developing a set of backend services, and this is common for backend developers who are building their infrastructure and offering services to others, your backend services would also call the Healthcare API FHIR servers. And so we provide several patterns for interacting with the FHIR APIs as a backend service as well. So there's a lot of documentation, like I mentioned, on getting started with the FHIR APIs and cloud healthcare. We've got user guides on how to authenticate, authorize to the healthcare APIs, how to get started with your first app, how to create a FHIR store. So feel free to check that out. The screenshot I have on the right-hand side is just to give you all a sense of the kinds of web services and API calls that we expose, right? So let's just take an example of something lower down the list in search. So one of the typical use cases for healthcare applications, especially digital health applications, is you've got data coming in, either patient generated or from other systems, and you're trying to, let's say, build an app that requires a complicated search at the back end, right? So one example could be, show me all the medications for this patient that have been prescribed in the last 6 months, right? And so if you were thinking of use cases like that, our FHIR server offers a pretty extensive set of search capabilities. So you can just create a standard FHIR search request, fire it off to our search API, and get back the results. You don't have to worry about anything that's happening in the back end. So there's a lot of such functionality for creating FHIR resources, reading, writing, updating, and even special FHIR operations. So feel free to take a look at our documentation and ask us questions on the Discord channel. So I want to talk very quickly about another aspect of building applications in healthcare, which is managing consent. So what we've realized over the past couple of years, especially focused on the digital health ecosystem, is the need for us to provide a scalable and secure solution for app developers to one, set policies around what users can consent to, how the user information is being used, and make sure that user information is not being shared in ways that users have not consented to, right? I mean, as we see more digital health apps being built, I think there's a lot of conversation in the community about purpose of use and making sure that end users understand what they're signing up for when they are starting to use digital health apps. And so we've built and launched a consent management service, which again builds on top of the core Google Health platform that allows app developers to do a few different things. One is be able to set the kind of language that users need to see when they're signing up for consent, right? They can also, as an app developer, you can prescribe what kinds of data is accessible to various parties that might use that research, right? And so one of the use cases could be that as an app developer, you're collecting certain kinds of health data from your users and you want to use that for analytics purpose, right? So you want to make it very clear to your end user on what purpose you want to use that data and what data you're collecting, right? And so the consent management API helps you set all those policies, tag the appropriate data with the right tags, and quickly figure out, has a user consented for a certain type of access, right? And as you think about sharing this data with other users, making sure that you're only sharing the data that has been consented to by the user. So our consent API has been in preview for a few months now, and we should be generally available very shortly. Please go take a look at our healthcare docs under the consent management part of it. And this is just a schematic of how consent works. I'm not going to go into the details, but you'll find this on our website as well. The story here is that we have the whole flow of how end users can figure out what consent they need to give to the app. The app is able to record what consent the user has given to the app, and while being shared to third parties, there's a set of search capabilities to figure out what can actually be shared, right? And so a lot of this is available online. Feel free to go take a look at it, play around with it as you're building your apps, and we're happy to answer questions on Discord. So with that, that was a very quick overview of the Cloud Healthcare API and consent management. I'll hand it over to Dharmesh for a quick demo for the FHIR APIs.
Perfect. Thank you so much, Kalyan. Let me move Dharmesh to the stage.
Right. Thanks, Aditi.
Of course. Thank you. Hold on 1 second. Perfect.
Awesome.
Hi, Dharmesh. Welcome.
Thank you, Aditi. And thank you, Kalyan, for providing us with the overview on Cloud Healthcare API. So what I'm going to do is I'm going to go over real quick on how can we use Cloud Healthcare API. How can we, specifically, Kalyan already touched upon this diagram and talked about different functionality that is offered in Cloud Healthcare API. What we are going to look at in this demo is how to instantiate this data store. We call it FHIR store here in this picture. How are we going to create that in Google Cloud? How can we import some FHIR formatted data into the store? And how can we access it through RESTful APIs? And this will give you enough information around how to use the FHIR store from within your mobile or web applications, whatever you are building for your hackathon. So I'll quickly go over this, and then we will take the question on the Discord. The way Cloud Healthcare API is organized, within Google Cloud Platform, we have a project. The project is created for a purpose or for a given environment that you are working on. Inside a project, you have to enable the Cloud Healthcare API. Once you have enabled the Cloud Healthcare API, you can create a healthcare data set, and that data set is tied to a given region. You can tie a data set to multiple regions as well. For example, you can tie a data set to US West or US East region in GCP, or you could just say this data set is tied to both US East and US West. And then within the data set, you can create multiple FHIR stores, one or many. For this demo, we will create one FHIR store and we will do all of our query execution against that FHIR store. But this is the architecture at a very, very high level. So how do I access my data once I've created this data store in Google Cloud to store my FHIR formatted data? Uh, we have a URL with this will be the standard host name for that URL, followed by a version. And then as your data store is created inside a data set, inside a given region, inside a project, you need to provide all of that into the URI or URL so that you can access that particular data store. And that makes it a unique address to access your data store within Google Cloud. So this is the example of different settings that you can provide to this URL. And we will see it all throughout my demo, how we are using this URL to access the data, to create some resources and so on. So we'll start with creating a data set. So you can create a data set two ways in Google Cloud. One is through the UI, which is called Google Cloud Console. So you can go to the Google Cloud Console, which looks like this. This is the Google Cloud Console. This is where your projects are listed. So once you have access to a project, or once you create a project through this button, you can access your project. In our case, we are using this project called HA Portal, and then inside this, you can create a healthcare data set by going to the healthcare browser, and that we will create our data set in here. Once you create your data set will be listed in over here, and then within that data set, you can create a FHIR store, and we will do that. So what I'm going to showcase is how can you create. So you can certainly create a data set using a UI like this, but we would use a quicker way, which is an API call that you could use. And in the Cloud Shell, which is a part of the Google Cloud Console, you can actually run a curl command to make an HTTP REST API call to this APIs to create a data set. So what I'm telling Google Cloud here is I want to execute a post, HTTP post on this URL. And this URL is what I was talking about, where we are saying the project is HA Portal, which is this. And then within that project, we want to create a data set called Healthcare DS, and we want to bind it to a location called US Central 1. You can do exactly same thing in the UI by providing the name of the data set over here, selecting a region or multi-region from this drop down, and then you can hit the create button. So what you can do with the UI, you can do it with the curl command here. So we'll go and create it using the curl command. And after the data set has been created, this is the response that comes back from the server, which gives you the operation that the data set creation operation has been kicked off. So now what you can do is once you go here, you can see your data set when it is created. So we can see that healthcare data set is now been created. Within this healthcare data set, you can create a FHIR store, create a data store, and then you can do it through UI, or you could do it through APIs. And so I'm going to make another API call. And in this case, I am making an HTTP post, one more HTTP post, but this time I'm providing that in addition to that data set, so within that data set, I'm creating a new FHIR store and providing an ID of that FHIR store as healthcare_FS. And I'm saying that I want to enable this capability on the FHIR store called enable update create, which lets me create a resource through put HTTP put call if that resource does not exist. And then I am also providing a version, FHIR version, and this is R4 that we are creating, Google Cloud Healthcare FHIR API supports DSTU2, which is the first version of FHIR, and then STU3, and then R4, which is the current one. Once you execute this, the response you get back right away is the information about the Firestore that was created. And then when we refresh this, we'll see that a Firestore has been created of type FHIR, and then the version is R4. Now what we'll do is I have some data, FHIR formatted data uploaded in Google Cloud, and we will use that data, we will import that data into this data set that we have created. But before I do that, let me showcase you a FHIR viewer. So when you go and open the FHIR viewer, and this FHIR viewer capabilities is still in preview, so it will be generally available pretty soon to all our customers. And this capability lets you examine what is there in the Firestore. So this particular Firestore that we just created will go and search for, let's say, a patient resource. And you saw the patient resource in Kalyan's presentation, where he went over how it looks like. There is no resources right now under patient type in the data store, because we just created, so there's no data in the data store. So what I'm going to do is I'm going to execute this particular API call again to import bunch of patients from this patient.nd JSON file that I have preloaded into Google Cloud Storage. Google Cloud Storage is another service in Google Cloud to store your files and objects. So you can use that to bring in your data and then import it into this data store. And the function that we are using on this Firestore, so now look at this URL. The URL is still the same up to the data set, and then the Firestore that we created. This provides the information to the server that this is the Firestore that I want to access, and then the operation that I want to execute on that Firestore is import. And what am I importing? I'm importing the data that I'm providing to this post HTTP call. So I'll execute that, and it's gonna start a long running transaction, and we can see the status of this long running transaction on the console through the browser by going into the data set and the operations tab, and it will tell you that this is the import resource operation. If you look at the operation ID, it is the same. It has been successfully completed. So now I should see some data in my Firestore. If I go here, look at my wrong one. If I look at the Firestore, and now if I look for the patient, I should see almost 12 records. So I have 12 different patient resources. I can select them. I can examine them in two different ways, through this tree-like user interface or the draw JSON. And this is a viewer. So we have a search type of capabilities built onto the viewer where you can search for resources by name and stuff like that. But you cannot edit or delete the resources through this UI, because this is viewer. Again, so going back, continuing with our demo, I think we covered the creation of the data set. We covered the creation of the Firestore inside the data set. Then we imported data, and now we have 12 patient resources in the Firestore. What we're going to do is now we're going to go and execute CRUD operations. So CRUD stands for create, read, update, delete, and we are going to do it through the RESTful API calls. And so the first thing we will do is we will add one more patient in this this Firestore using an HTTP call. And in this case, we will use HTTP post. And what we are doing here is, and in fact, I'll have to cancel this, sorry. I'll have to go to the directory where I have this patient.json, but let me walk through this before I execute this. So we are doing HTTP post, again, the same URL, which identifies which Firestore we want to put it. And then we are adding this FHIR patient. This is as per the FHIR REST API specification. and HL7.org have clearly defined the specification for how you can access FHIR data through RESTful API. So this is standards compliant. This is the standards way to access the data. Uh, and this patient.json is the local file that I have on my Cloud Shell VM. So let me go to uh, I have my patient.json here. So I will go and I will execute the same HTTP post to create a patient in the Firestore. So it's going to take the data from this patient.json. We will look at what is in that patient.json real quick. So this is the patient.json file. I've opened it in another tool that Google provides called Cloud Shell Editor, which lets you edit files that you have on your Cloud Shell VM. And this is the patient resource that we are trying to insert into the FHIR resource or create inside the FHIR resource. And as you can see, the gender is female, the name is Amy here, Amy Shaw, and then the address is here. We don't have this patient currently in our Firestore, and after we create, we should have that patient in the Firestore. So that REST API call successfully executed. It returned back with the resource that was created. There was no resource ID in the file itself. So what it will do is it will generate a resource ID, and this is called the resource ID. So it's important for us to remember this. And now if I go here and refresh this browser, then I can see there's one more resource that came in. So there were 12 patients before, now we have 13 patients. I can go and examine that, and the viewer gives me the ability to look at it. Is it the same patient that I inserted? And yes, it is Amy Shaw with the address and the date of birth information that we provided. So that's how we would insert a resource. And then you can also query the resource through uh, HTTP GET operation. So let's do a read now. So now try to query the same one. So let's say in your application, you want to query this particular resource. You can do an HTTP GET, provide a URL, and then provide the name, identifier of the resource, and run an HTTP GET, and that's how you can get this resource data back from the FHIR server. This is all you can do it in your mobile app or your web app, whatever you are building. But this is a nice way of storing your data in a standard FHIR format inside the data store, and you don't need to worry about provisioning a database server or provisioning any hardware or software or anything like that, or bringing in licenses. So let's move on. So after create and read, let's do an update. So what I'm doing is now I am updating the patient resource that I already have by using HTTP put. There are two ways to update a resource in a Firestore. One using HTTP put, another one using HTTP patch. What we are going to look at into the put and then later on in the patch. So for the put, we are using another resource, which is a copy of the same resource, but this time we are providing an ID in that resource, and we will change few attributes of that. So we will take the ID of Amy Shaw that was generated by the server, and we will modify it for this patient. And then what we'll do is we'll also modify maybe a few other attributes like the date of birth, right? Let's say we change it from 20 to 09. And so 9920, and maybe we add the wrong address. By mistake, somebody has entered it, or wrong date of birth, we change that. And now what we are going to do is we're going to update that existing patient by using an HTTP put. Okay, so I think we have an issue because the URL has a different ID and the resource has a different ID. The URL should have the same ID as the one here. So good. We put the ID and then I think it should go through now. So that's how we updated the patient. And so now if we look at Amy Shaw again, we will see that the address has been updated and also the date of birth has been updated. So this is one way of updating a FHIR resource in Google Cloud Firestore. The other way is through the patch operation. So on the patch side, what I'm doing is I am not providing the entire resource, but I'm providing the element that I want to update. And then in the URL, I have to provide again the same identifier. Oops. So in this case, the data that we are providing is only updating the date of birth, and we are not updating all the fields. So this will be more efficient. If you want to update just one field in the resource, and it's very important to understand the way you provide this data is you provide an operation, what you want to do, replace or remove, and then path to that in the JSON. So this is a JSON path expression and then the value. Once you do that, I think it should, okay, I think I got a wrong ID here. It should update the patient's date of birth from 9/9/2007 to 9/7/2007. And that's essentially how I will do the updates. And finally, the last one is, or I have two more, sorry. One more is how do you search data from Firestore? So again, through HTTP GET, you can use the same URL that you looked before for retrieving a particular patient resource. This time you're providing a query string like this. Family is Shaw, address has city Mounds. So when you provide like this, then it will give you a result set. So now what you get back is a resource, not a particular patient, but a result set called search set. And the resource was type bundle. And in that you will have one record written, which is for Amy Shaw. And there are different ways to search a resource from a Firestore. And the search specification, what you can provide in the query, what type of logical operators you can use, what type of other type of include type of operations you can use. All this is as per the hl7.org FHIR specifications. And so you can read more on the hl7.org website about this query syntax, but that's a standard. So it is standard based, and it is not something that you have to learn as a new way of writing these queries. So that's how you would search. And finally, I will go ahead and delete a patient, the one that we created, and that's you will use HTTP delete for that. So I'm using HTTP delete, and I will delete this patient that we just created. And and then what you get is an empty uh, JSON element, and there is nothing essentially. So what it means is that the record has been deleted. And if you look at the full HTTP response, you will get HTTP 200, which says the response has been successfully executed. So now you have only 12 resource back. You're back to our state. So with that, I think I'll quickly summarize what we did. So we created a resource. We accessed the resource through using the identifier. We updated a resource using put. We updated a resource using patch, where you can patch a particular field. And we saw how you can potentially do a search on the Firestore and how you can delete a resource. So that's how I would access data from my data store. So this is all the information that you need to use the Firestore right now. And then additional links are available uh, as a reference over here that you can use to read more about it, learn more about it. And then if you have any other questions, we'll be around on Discord where we can help you uh, answer those questions.
Great. Thank you so much, Dharmesh. That was very, very useful. All right. And Dharmesh is going to be around on Discord answering questions. He's quite the superstar, and he always wants to help out as much as he possibly can. Next up, we have Andrea Bodnari. She is the product manager at Google Cloud. And in her role, Dr. Bodnari is responsible for the business strategy behind AI products and solutions for healthcare and life sciences. She leads cross-functional teams from a product's conception through to its launch. And before her current role, Dr. Bodnari was the founder and CEO of a robotic process automation company for financial services. She has over 10 years of experience driving technology adoption in large organizations. And she successfully managed digital transformation initiatives for healthcare, for insurance, and financial enterprises, and has worked with startups from bootstrapping all the way through a successful acquisition. Dr. Bodnari holds a PhD from the Massachusetts Institute of Technology and is focused on artificial intelligence. She received her Bachelor's of Science degree from WPI in Massachusetts. And with that, let's welcome Andrea to the stage. It is such a treat to have you here, Andrea.
Thanks for having me, Aditi. I'm very happy to be here and share with the audience what we're building at Google to enable AI applications in the healthcare industry.
Perfect. Now, if you want to share your screen, I will move it to the podium.
Absolutely. Okay.
Perfect. There you go. The stage is all yours.
Fantastic, fantastic. So everyone, today I prepared a quick overview of how Google is thinking about enabling productivity in the healthcare and life sciences space. We are enabling productivity with AI applications that augment how the healthcare professional is able to deliver on their job. And for today, just to give you a high-level overview of why we're doing this work and why it's so timely that AI applications become practical in the healthcare industry. If you are to look just at the impact that the COVID-19 pandemic has had on the industry, there's been a high surge in demand for healthcare services, but the workforce cannot scale elastically to meet that demand. And especially in the healthcare space, we've seen for a large number of years that healthcare professionals have to spend a large percentage of their time documenting the patient interaction. And that process takes time. There's a prediction that the workforce gap will reach a vacancy rate of 30% by 2024. So if we are to look at the status quo, we have to beg the question of how can we help and how can we make these healthcare professionals more efficient at their jobs. So we, as Google, have decided to make an investment in seamlessly sharing patient information to avoid processing delays. We are building AI that can identify and eliminate errors that might require corrective activities done by humans. And we are building AI that can move low-value activities away from employees by automating mental tasks. And with this AI technology that augments the human, you will enable employees to work at the top of their license. And some of this mythical AI I've been referring to is actually the Healthcare Natural Language API that we have released in November of last year. In healthcare, a large percentage of the data that gets exchanged and reviewed by humans is unstructured. And when I say unstructured, I'm referring to the fact that the data is not organized in systematic formats that the computer can comprehend. 80% of this health data is unstructured, and because of that, it's difficult to analyze at scale. The data in healthcare gets generated at multiple sites. You have the bench site, basically the places where drugs get developed. And at the bench site, you have unstructured data sources like pharma databases of research reports or scientific literature that are published for the broader public community. There's another site where healthcare data gets generated and is unstructured, and that side is the bedside, where the patient gets the services, the healthcare services. At the bedside, we are looking at unstructured data sources like the medical notes, the lab results that are published in more of a PDF, tabular format. And in the community, we're also seeing unstructured data sources being generated in the form of consumer reports, telemedicine conversation, or the reports that have come out of the Internet of Medical Thing devices. All of these unstructured data sources can be processed now systematically at scale with the Healthcare Natural Language API from Google Cloud. And this piece of technology enables you to take unstructured data and map it into a structured representation. The Healthcare Natural Language API enables you as a developer, as an organization, or as a business user to map text to a longitudinal patient record. And what do I mean by that? When you look at a piece of text at a medical chart of a patient, we as humans can identify insights that might be meaningful, and a healthcare professional can identify insights that are distributed across a time scale, that are distributed across the likelihood of relevance to the patient's current health status. We've taken AI deep learning algorithms and we've trained them to do the same type of analysis that's done by a healthcare professional. So when our AI looks over a medical chart, it identifies medical insights, it qualifies those medical insights with contextual modifiers, and it also assigns different healthcare relevant dimensions to these medical insights. One of the dimensions of clinical relevance that's attached to each medical insight is the time dimension. And time is very important when you are taking care of a patient, because you need to know what's critical, what's urgent, versus what's a medical episode that took place in the past and it's no longer applicable. So let me go into detail and walk you through the different type of analysis that can be performed automatically through the Healthcare Natural Language API. The Healthcare Natural Language API consists of a number of core features under the hood that help you find, assess, and link the knowledge in your data. These core features are a knowledge extraction module, a relation extraction module, a context assessment module, and last but not least, a knowledge linking module that basically normalizes all of the medical information against industry standard dictionaries. So I'll go through each of these modules one by one. Knowledge extraction maps text to medical concepts. So if you have a medical chart, the Healthcare Natural Language API is going to ingest that medical chart and identify mentions of medical conditions, medical procedures, anatomy, or social determinants of health like substance abuse. So all of these categories are basically pre-trained, baked into the Healthcare Natural Language API. This is functionality that is available off the shelf. And behind the scenes, we at Google have built deep learning approaches for extracting this information with high specificity. The next module of the Healthcare Natural Language API is a relation extraction module that identifies and connects related medical attributes. So I talked earlier about medical conditions that can be extracted off the shelf with the Healthcare Natural Language API. If a medical condition is present in a medical chart or in a piece of text, the Healthcare Natural Language API will scan the surrounding text to identify any anatomy sites that are linked to that medical condition, any medications that were prescribed for that medical condition. If a medication is being identified, then the Healthcare Natural Language API will scan the surrounding text to pick up the dosage, duration, form, route of administration. And these are just some of the medical attributes that are automatically extracted through the Healthcare Natural Language API. And for a more detailed list of all the different attributes, you can reference our public documentation. The following module, context assessment, picks up surrounding factors that could be clinically relevant. There are 3 dimensions we assess when we talk about clinical relevance as part of the Healthcare Natural Language API. There's a certainty dimension, a temporal dimension, and a subject dimension. Certainty is a nuanced dimension, and I want to highlight that certainty refers to the certainty of the medical professional that wrote the piece of text, the medical chart, and it doesn't refer to the certainty of the underlying deep learning model that extracted that information. The Healthcare Natural Language API will surface the certainty of the deep learning model, but the certainty field that is retrieved as part of the JSON payload, that refers to the certainty of the medical professional. And the reason why it's important to know how certain a medical professional is, in certain instances, a medical professional might say the patient might have diabetes, and that is a likely diagnosis, versus the instance when the doctor says the patient has diabetes, which is a likely diagnosis. So that is the function performed by the certainty dimension of the Healthcare Natural Language API. Next, with the temporal analysis, you will get an assessment of where on a linear timeline the medical episode occurs, if it's current, part of the clinical history, or upcoming. And the subject dimension will associate the medical episode with the patient family member, or someone else. Last but not least, once all of this knowledge gets lifted from a text or a PDF by the Healthcare Natural Language API, the knowledge linking functionality that's baked into this API standardizes medical concepts so they can be analyzed across systems and across medical terminologies like LOINC, MESH, ICD-10. There is an important piece of functionality that we as Google Cloud are making available to our end users so they can complement the type of analysis that is performed on medical text. Specifically, I talked about a number of analyses that are performed automatically by the Healthcare Natural Language API. If you want to complement that type of analysis and extract additional social determinants of health, like lifestyle habits, you can build your own custom model in AutoML Healthcare. And AutoML Healthcare is available both via the command line and a user interface. All you need to bring to the table is data, some subject domain knowledge to know how to annotate the relevant instances of the information you want extracted, and Google Cloud takes care of the model training deployment at scale on your behalf. Now, in terms of our roadmap, today, the Healthcare Natural Language API and AutoML Healthcare are available in public preview. We are going to GA in Q2 of this year. There are additional capabilities that we're bringing to the table. We are launching ICD-10 and STROM-SCT in this quarter. They're going to be available as part of the API itself. And we are also planning to bring to the market a more integrated offering so you can do end-to-end processing of medical charts that are available in PDF formats, as well as extract additional data points like date of service, physician information, or map into additional dictionaries like CPT. In the interest of time, I will wrap it here, and I'm going to pass it on to Aditi, who will introduce the next speaker.
Great. Thank you so much, Andrea. I just want to say thank you for being here. I know it's really, really busy right now, and so I appreciate you spending some time.
Thank you for having me. I do appreciate this opportunity.
Of course. All right. Then next up is our final speaker. We've got Rohit Talreja. Rohit is a product manager on the Google Cloud Healthcare and Life Sciences team, leading data governance product initiatives. And in this role, he works to provide customers with products and solutions to secure their data and manage their workloads on Google Cloud. This includes tools for data harmonization, compliance management, access control, and data labeling, among others. And these products allow for innovation in healthcare through applications of artificial intelligence, collaborative research, and cross-org collaboration. Now, previously at Google, Rohit has worked in the areas of security, privacy, and AI, all near and dear to my heart. So woohoo for Rohit. And prior to Google, Rohit worked as a software engineer, and he spent a short time teaching undergrad CS and anatomy physiology courses. Rohit holds a master's in science in computer science and a bachelor's in science in bioengineering, both from Stanford University. So with that, I want to extend a warm welcome and bring Rohit to the virtual stage. Thank you, Rohit, for being with us today.
Thank you very much, Aditi. It's awesome to be here and speaking with everyone today. As you said, I'm going to be talking quite a bit about the security and privacy enablement that Google has for cloud services and cloud-based applications. This is a topic that I'm sure a lot of people are no doubt curious about. Some people might even be concerned about, but definitely a lot of people are interested in. So, without further ado, I'll just dive right into some of the solutions that we have available. So, kind of an overview of how regulatory compliance affects the healthcare industry, right? So if we focus specifically just kind of on the provider and side for a second, ignoring, the large swath of other healthcare and life sciences organizations, but just on in the provider world, hospitals are estimated to spend about $40 billion a year just on administrative activities related to compliance, right? So this is everything from documentation to personnel to IT systems to auditors and vendors who help with these processes. So there's a lot of work involved in this $40 billion, but still eats into quite a bit of the time that could be spent on patient care or could be spent innovating in the healthcare provider's core business. This has a pretty big toll on clinicians as well, right? So an average size hospital seems to dedicate about 60 full-time employees to regulatory compliance, about which a quarter of them, so 15 or so, are doctors and nurses, right? Again, this speaks to the human impact of compliance and potentially thinking about how these clinicians' times are being spent, especially as more and more is expected of our clinicians every year. And then finally, compliance kind of has a burden on patients as well, right? So the frequency which regulations change often result in duplication of care. I think everyone has heard at least one story where a patient had to take duplicate tests when changing between health systems because the records couldn't move as easily between them. And then again, this takes more and more time away from patient care. But when we talk about regulatory compliance, it's important to kind of break this down and talk more specifically about where this actually comes from. I think in healthcare, a lot of organizations have a tendency to lump everything under compliance or regulation. And breaking it down actually helps understand where specific requirements come from and how they are intended to be met. So this first category is data privacy regulation, right? So these are things that almost everyone is familiar with. It's things like HIPAA in the US for the collection, use, disclosure, sharing, etc. of protected health information, among other things that are outside of the data privacy domain. And then similarly, GDPR in the EU, which is a much broader regulation, not just focused on healthcare, but has a large impact on the collection, processing, and transfer of personal data. Both of these organizations kind of have scopes of organizations that they apply to and don't have a formal certification, right? But still, this kind of forms the legal basis related to data collection, processing, and sharing. It sets up a compliance framework and a penalty framework as well for any non-compliance. But the most important part here, and I think this is what trips up a lot of organizations, is they're generally descriptive standards, not prescriptive standards. That means there's no official certification. It doesn't say you must do X using this set of processes. It basically says you must protect patient data and only use it for these set of use cases. But there's a lot of room for interpretation, which leads to a lot of anxiety sometimes in meeting these compliance requirements. Next, we have government frameworks. I think these are applicable to sections of the healthcare and life sciences industry, so maybe not everyone is familiar with them, but basically they're the requirements for doing business with government agencies. So for organizations that have government contracts or are vendors to other organizations that have government contracts, these may be familiar in some domains. So frameworks in this case include FedRAMP, which is specifically a US government requirement for cloud service providers. It's very prescriptive in contrast to the privacy regulation. This has hundreds, maybe thousands of controls which are specific in how they must be met. They have very clear alignment criteria and assessment criteria. And finally, there is a formal certification process. So while HIPAA compliance is a little bit of a challenge in deciding where the bar is in some applications. FedRAMP and similar analogs are very clear. There will be specific controls, and at the end of the process, you either get the certification or you don't. Next, we have industry standards, and industry standards fill kind of a gap in the data privacy regulation where some organizations are looking for more prescriptive requirements. So these are self-regulated committee-based standards for a specific market segment or use case that have a prescriptive set of controls and a prescriptive audit framework. So importantly, participation is voluntary, but is often contractually enforced through business agreements or purchasing frameworks. So in some cases, organizations are complying with HITRUST as a prescriptive standard that tries to operationalize legislation like HIPAA, GDPR, and so on. Or organizations are aligning to PCI DSS, where they collect and manage payment card information in the process of doing billing for healthcare. And lastly, there is an area called GXP, and GXP specifically comes up a lot in the pharmaceutical and life sciences domain, but does cross over into the healthcare side as well, where there is an overlap between the domains. So GXP here is a combination of everything. There's some regulation, such as the CFR 21 Part 11, which often gets included in GXP. There's industry standards that get grouped in here, institutional and tribal knowledge, and other controls that cover a lot of the topics that are on this slide. So GXP is again, a little bit of a nebulous area, but very important when talking about R&D, taking medical devices and pharmaceuticals to market, and also making sure that the follow-through process on these products is consistent and comprehensive. All right. So after that overview, it's important to think about the ways that Google Cloud can enable organizations to meet these compliance requirements and ideally exceed them. So the way we do this is first we provide baseline protection against threats through a secure cloud infrastructure foundation. Our core infrastructure is designed, built, and operated with security in mind, and I'll talk through some examples in a second. Second, we provide our users with a constantly expanding set of controls that they can use to meet some of these regulatory compliance frameworks, as well as industry standards, as well as their own business objectives. And then finally, we work with external and internal compliance experts to meet our own compliance requirements as a business associate, a service vendor, et cetera, and provide capabilities to make the process easier for our users. So let's talk a little bit more about what I mean that the cloud is designed with security in mind. Our infrastructure doesn't really rely on any single technology to make it secure. I've often seen in talking with some other healthcare organizations that their security model is a fairly thick perimeter. And you can think of this as a combination of network defenses, identity defenses, et cetera, but really only around the perimeter of their environment. It's a very robust control for that level. But once you're inside that perimeter, perhaps through a phishing attack or a targeted attack on some network device, everything inside that network is really flexibly discovered, flexibly accessed, and easy to exfiltrate data. And I think Google Cloud is built in exactly the opposite way. So rather than having one single technology or tool to make the environment secure, we rely on progressive layers of defense in depth that deliver protections at each layer of the stack against different types of vulnerabilities and attacks. So starting with the hardware is Google controlled. We have full provenance and control over the hardware itself. It's built and hardened to our specifications. And then going above that, any application binary that runs on our infrastructure is deployed securely. We don't assume trust between services, and we use multiple mechanisms to establish and maintain trust between devices. There are some hardware components that are physically present on the chips that establish a root of trust, as well as software protections that establish trust and identity between services that are trying to communicate with each other. So going up to the next layer, data stored on the infrastructure is automatically encrypted at rest, and I'll talk a little bit more in a couple of slides about how that happens. And then also communications over the internet to our cloud services are also encrypted. This sheer scale of the infrastructure is also a security protection, right? We have built-in denial of service, attack prevention, mitigation, and threat response that further reduces any impact of DDoS attacks. And finally, we have an operations and security team that detect and respond to incidents, every hour of the day, every day of the year. All right, so going into just a couple specific controls and features, one of the most important ones is encryption at rest by default. There are service providers that offer optional encryption capabilities, and we took a very different approach. I already mentioned that communications over the internet to Google Cloud require proper TLS connections, but once data reaches our infrastructure, it's encrypted at rest by default. And how that happens is data is first split into multiple chunks. And the idea here is that each of these chunks gets encrypted with a different key, such that it takes multiple chunks of data and multiple keys to reconstruct the original file. And this is partly for performance, in that we can distribute these chunks to different parts of the infrastructure and have them readily available with proper disaster recovery in place. But it also, in a large sense, is for security, in the sense that now we have multiple keys that could potentially need to be accessed or compromised in order to reconstruct the original data. So once the data is chunked and encrypted, each of these keys actually gets wrapped with its own encryption layer. And then the data and wrapped keys are distributed to different pieces of storage infrastructure. This could be different storage devices on the same server. This could be multiple servers attached to the same network. Basically, the performance and security go hand in hand here, and we try and do both at the same time. All right, so I can't really talk about everything that is protecting the infrastructure in the span of maybe a 30-minute talk. If we had 30 days, I could maybe cover it all. But basically, the summary is we have a very strong defense in depth security program. We've thought about what specific attacks and vulnerabilities could be present at each layer of the stack, and designed very thoughtful, very comprehensive ways involving both technology and operational measures that prevent and mitigate any sort of security breaches in the infrastructure stack. And the result is really very comprehensive protection of the cloud platform that's made available to our users as well. All right, so at this point, I'm going to pivot a little bit and talk about how these default protections can get applied to user environments as well, and what sort of controls are in place to help users manage their own security and compliance. I think most people are familiar at this point with the shared responsibility model of cloud platforms, but just a very quick overview. There is an idea and a very real application that there is a shared responsibility in protecting cloud environments. There are some capabilities that are the responsibility of the cloud provider, in this case, Google Cloud, for securing the hardware, creating secure cloud services, building a secure network, and so on. And then there are some responsibilities that rest with the cloud user. In this case, it's what data is processed and stored on the system, how are databases configured, who does the user give access through their IAM settings to the data and the cloud environment. Those type of controls are things that are outside of the cloud service provider's purview. And in this case, the user needs to make sure that they're doing things appropriately. But on the other hand, the cloud provider can always provide best practices, templates, products, and solutions. And then in a few slides, I'll talk about all of the different options that Google Cloud has available for this. So to make this example real, talking about the shared responsibility framework, I'll go through a couple examples, one for an infrastructure as a service product, one for a platform as a service product, and finally one for a software as a service product. And I'll show kind of how the responsibility split changes as we walk through the different types of products. So if we see here, our virtual machine management product, Compute Engine, basically provides virtual machines that are customizable with different parameters. So different amounts of CPU cores, different amount of RAM, different size attached storage media, GPUs, etc. Right? So basically, any sort of virtual machine you want, this is the service you would go to spin it up and manage it. So the cloud provider, Google Cloud, has taken the responsibility for securing the physical hardware, the boot and the host operating system, the host kernel, the physical storage media, and the physical network, as well as providing robust audit logging and access logging for the physical and virtual devices. But it very quickly transitions into user responsibility here, right? Users are in control of what guest operating system or applications they run on the virtual machines. They're responsible for configuring their virtual private network and firewall rules for the VMs. And then all the way, going up the stack, they're responsible for configuring security scanners to detect breaches, DDoS attacks, etc. They're responsible for controlling usage of these VMs, and finally giving access to people within their own organization access to run services on these VMs. So if we take a step to a platform as a service solution, BigQuery, which is our managed data analytics warehouse, you can see that Google Cloud's responsibilities have kind of shot up the stack. We're now responsible for quite a lot more, including managing the underlying infrastructure, managing the virtual infrastructure, and also managing the auto-scaling capabilities of the service. The customer IT responsibilities have proportionally shrunk, right? They're still responsible for choosing what data goes in the system, choosing who in their organization can access this data warehouse, and configuring some level of security on top of the service. And then finally, going to a software as a service product, Google Drive, which is our managed file uploading, file backup, and file sharing application, part of the workspace suite. You can see that, again, Google Cloud's responsibilities have gone way, way up. We're responsible for maintaining the security of the application, provisioning operations that auto-scale based on the amount of data that users have. But there's always going to be some minimal set of customer responsibility. In this case, it's what data do they put in the system? What are the access policies for that data? Do they share it with all members of their organization or only a few? And then making sure that data in their instance of Google Drive is properly managed. So I'll contrast all of this with the traditional on-prem IT model, in which case, obviously there's no Google Cloud responsibility because it's all on-prem and entirely customer IT managed. And in this case, there are a few trade-offs. Obviously, there's greater flexibility sometimes in the on-prem space, but that also comes with much greater responsibility. Responsibility to maintain physical machines, cooling systems, power systems, space rentals, etc. And then also a lot of responsibility on the security side, right? Because Google Cloud is not taking any of the responsibility for securing an on-prem environment. Customer IT has to take that on entirely. So the shared responsibility model has a lot of these trade-offs, but it, on the whole, works to the benefit of the user. The user gets world-class secure services at maybe a little bit of a trade-off in flexibility of not having to maintain an on-prem system. All right, so this slide looks very similar to one I showed previously, but it actually is the kind of customer-facing controls that Google has built into the platform. So very similarly to the defense in-depth approach that we do internally, we offer a number of capabilities for users to run their own defense-in-depth security program. So we have virtual private cloud networking tools to help customers prevent unnecessary exfiltration, limit the network traffic to a particular set of applications, etc. We offer different options for key management when encrypting data at rest. Remember, I mentioned that data is encrypted at rest by default, but we offer a number of different options for how those keys are managed. And then finally, as we go up the stack, there's a built-in security scanner that can be configured and run across the entire web application suite, and then identity and access management controls across the platform. All right, so tying this all together, Google Cloud's goal here is really to have a comprehensive security and compliance program that covers not only our own compliance obligations. As you can see, we've done a number of external audits and certifications to demonstrate our commitment to compliance, specifically a number of options in the healthcare and life sciences domain. And then also our commitment to helping customers manage their own security and compliance obligations. A number of these certifications can be used as evidence by our users when they're getting their own audits done and saying, we're using a platform that has thought about these things and that has gone out and gotten certifications or alignment with a number of these compliance programs. So in the last section of the talk, I'm going to get a little bit technical and talk about a specific tool that we've released in the open source domain to help users securely and quickly provision cloud environments. We call it the Data Protection Suite. So the Data Protection Suite workflow consists of 3 user journeys. The first user journey is deployment. So for deployment, this is using Terraform, which is a very popular infrastructure as code automation tool, and a mix of our own command line utilities and CI/CD pipelines that enable easy, verifiable, and reproducible deployments of common solution architectures. So we've built a number of sample templates that can be used to deploy architectures for data warehouses, AI/ML pipelines, application hosting services, etc., that can be deployed as is for a secure baseline or further extended and customized by you for your, custom business requirements. So the benefit of the deployment suite here is it's built-in automated deployment validation. So this helps you determine very quickly, did what we actually want deployed get deployed? And if that didn't happen, what were the errors? And were the right security and compliance protections deployed along with it? The other benefit of the deployment tool is it's fully integrated with the second piece, which is the monitoring user journey. And the monitoring user journey here helps you define governing policies across GCP resources. So this lets you control what regions the data resides in at rest, what services are allowed to be spun up between the environments, what happens to the audit logs when they're created. Do they sit in one place, or are they centralized for easier triage and incident response? And then finally, this provides a periodic or continuous scanning framework that automatically interrogates the live state of the environment against the governing policies that you configure, and will create alerts or other sort of monitoring reports to allow you to triage and investigate any issues. So the deployment and monitoring being so tightly coupled is actually a pretty big win in this case, because it allows you to fully integrate your workload with a monitoring framework that prevents drift in configuration. And then finally, there's an auditing piece that allows you to visualize audit policy violations and locate the right audit logs to help triage and remediate. So going into a bit more detail, this is a very high level block diagram of just how the service works. There are a number of libraries that we work with in the Terraform side, in the Cloud Foundation side, that basically have templates. And these templates, like I said, define reference architectures and pre-configured ways of deploying cloud services. They kind of go through this data protection toolkit, data protection suite engine, and get converted into a Terraform file. And then this Terraform file can be used to deploy multiple environments on Google Cloud. One example being production, dev, and test that are identical or differ in specific ways to allow you to run workloads in production, test them on the same infrastructure, and do development on the same infrastructure. And this helps meet a lot of those GXP requirements, for example, right, where you're testing, developing, and building on the same infrastructure. So this is an example of what one of these templates might look like. It says what this does is it's setting up a BigQuery instance, which I said was one of our data warehouse products. It sets it up with a TTL for the data, a set of access groups, and a set of viewer groups. So basically, this is kind of prescriptively defining what the infrastructure is going to look like, and then it can be included as a module in a larger template. So if you imagine, this BigQuery instance as part of a larger application system or a larger data warehouse solution, this is just one of the modules that may exist, and other modules would look similarly to it. They can get quite complicated in terms of the configuration settings you can set, but this is the basic example to kind of show how it works. But I also mentioned that monitoring could be brought into this as well, right? So this is how you would configure a monitoring rule. So the monitoring rule here says these are the allowed policy member domains. Basically, these are the user domains that are allowed to access data in this project. And then these are the VPC networks that this instance is connected to. So basically, if a user outside of one of these domains tries to access data, there will be an alert. If a VPC network outside of the ones listed here tries to access this storage instance, there will be an alert. And basically, the scanners can run at configurable intervals. We defaulted them to 12 hours, but again, fully configurable. We have some users running this every 10 seconds just to get a continuous picture of their environment against some of these available monitoring policies. And finally, there is a tool in the Cloud Console that allows you to visualize, understand, and track these policy violations. So data from the monitoring scan kind of gets included in an auditing tool for triage and investigation. So tying it all together, I said we had an automated template for a basic HIPAA-aligned project. This is kind of what that solution architecture looks like for that base project. There's infrastructure for connecting to on-prem systems. There's infrastructure for a main data hosting and application project. And then finally, there's a security operations project that stores audit logs, access logs, event logs, etc., and then runs that monitoring tool set. So this is a very base framework that can just kind of be stood up in an hour or less on Google Cloud, and then you can drop kind of your custom workloads or custom applications into it or extend it for additional requirements. And that just kind of helps get up and running faster. So just to tie everything together, we talked quite a bit about how Google Cloud manages our own security and compliance. We talked about the controls and features and certifications that are available to users to rely on to manage their own security and compliance. And then finally, we talked about one specific tool set, the Data Protection Suite, that helps accelerate migration timeline. It decreases the burden of the security and compliance overhead and makes it easier and faster to get up and running with your core business needs. And then finally, it helps pre-apply business practices for security and compliance. So with that, I will turn it back to Aditi. It's been a pleasure speaking with you this morning or this afternoon.
Thank you so much, Rohit. Really, really exciting stuff. And I encourage everyone to look at the online documentation. It's very, very detailed. And then the GitHub site too, I've posted a link to that on the Discord channel. So be sure to check that out. Thanks, Rohit.
Thank you.
All right. That is a wrap for day 4 of our Tech Talks. Now, home stretch. Tomorrow is our very last day of Tech Talks. We have a really jam-packed agenda from the Android team for you, talking about the Google Fit API. And then I've invited the Commons Project team to talk about the Android version of HealthKit. They're a nonprofit funded by the Rockefeller Foundation, so I think that'll be really helpful. And then after that, we'll do a deep dive into Firebase. And then the Firebase team is going to talk a little bit about what are the 3 steps that you need to take immediately during the hackathon to be able to work with Firebase. And then we'll wrap up the entire series of Tech Talks for the week with the awesome Professor Stern from Harvard Business School. She's going to give us some perspective on what healthcare will look like post-pandemic. All right, so I am going to be signing off for now, but I will be around in the Discord server to answer any questions that you have. So see you all tomorrow. Look forward to it. Remember, tomorrow is our very, very last day, so be sure to join us.